Frequently we get asked to do technical publications and white papers and present them at conferences. This particular year we've done several on the area of automation services and trends in that arena. However, most of the time ABB people don't actually get to hear those. It's our customers and our clients. And so you get to watch a paper or a PowerPoint, which will be available with the presentation. But we've never been able to capture the meeting and present it to the people in ABB so that we can have it. And so this is kind of a first attempt at capturing a knowledge video and call it a knowledge vault. And that's what we're trying to get your feedback to see if this works, if you like it, because we've done several technical papers, 10, 20 over the years, that are Word documents and PowerPoints in a directory someplace. And you just don't get the same feel when the person that wrote the paper is presenting it. So this is an example that you're about to see trying to reenact a presentation at a technical conference. This particular one was just given at the ISA show in Nashville. We're going to be giving it again at the Pulp and Paper show, it's also in Nashville. And I also just gave it at the Offshore Europe show in Scotland. And I was just interviewed for publication in Automation magazine on automation trends. So this apparently is sort of a hot topic in the industry, and people are asking, what is automation service? This is what we're going to talk about. Hi, my name is Kevin Starr. Today we're going to be talking to you about automation services for the 21st century. Recently we've had an influx of questions from our customers, trade shows, and even editorial magazines on the subject of automation service solutions. In response to that, ABB has produced this white paper that we're going to go through today. Today we're going to cover, well, first of all, what is automation service? What do we mean by that? Why do we need it? Are there any benefits? And how should it be structured? This particular picture I really like because it tells the story. What you can see in this area is all industrial processes convert a raw material into a product. Whether it's a tree into a piece of paper, a rock into a precious metal, oil into plastic. You know, there's an industrial process that converts a raw material into a usable product. The equipment that is used to do that transformation is very different. You know, paper mill is different than a distillation column, different than an offshore oil rig. However, what's interesting is the advances in technology have allowed the automation equipment to be very, very similar. A controller can work, you know, a flow, a pressure, a temperature, a level, an operator display is actually the same in a wide range of industrial applications. 20 years ago, that just wasn't the case. So at that time frame, service on the equipment was and still is essential to making sure that the transformation of material to a product is done. However, we have added automation solutions to increase throughput, increase production, quality, and reduce the cost to produce. That's what we're seeing here in this picture. Is now we have more data than we've ever had in the past. And without an automation system, when you're controlling it by manual methods, waiting for a reaction before you make a control, you typically have a wide variability in the spread of your quality data or your production data. By adding automation equipment, we're able to reduce the spread of that variability and allow you to have a wider range of control of your industrial process. A wider range of control allows you to run faster, run longer, run smoother, have less wear and tear on the equipment. That's why automation solutions are even put in place to begin with. But along with those automation solutions requires an automation service. This pyramid illustrates the complexity of an automation service solution. You have to have actuators that work. The actuation has to be there. Something has to move the actuators. Today, with smart actuators, the resolution and the precision is something we never had before. Instrumentation, smart instruments, protocols that can tell you everything about them. There's more data coming from an instrument than we've ever had before, and at more accurate and less tolerance and error to the measurement. The utilization of the control system. We as a manufacturer of automation equipment didn't design it to be turned off. If the control is not running, it's broken. Data storage. 20 years ago, there was no such thing as data storage. It just sort of flowed through. We would get called in, and I'll show you a picture here in just a minute of what we mean. But today, we have gigabytes, trillibytes of information at our fingertips. The platform, there used to not be a control system platform, now there is. Software applications that can pull together multiple layers of control strategies from multi-input, multi-output to feedback to there's feed forward, ratio, min-max. There's so many different applications that we can do through software that weren't even possible just a few years ago. User displays, are they set up for your operators to get the information they need? It's no longer okay just to look out over the plant. They need to be able to look into the plant. User displays, alarms, triggers, what's the alarm rate that's going through your operators? Is it set up right? The information that's coming to them has to be aligned with their response time in mind. Variability, this is the area that I tend to migrate towards, is production variability. What's going on in your process? Causality issues, input, output, bottlenecks. How do we fix that? And the reason we do all this stuff is to get to the top of the pyramid here, which is money. The better your automation system is functioning, the more production, the more quality, the less cost to produce that you have, which is more money in your pocket. That's why we have an automation system. But with that system requires service. This is an actual picture that I took 20 years ago in an industrial plant. You can see here, this was the definition of an operator display. These are quartered in controllers that would line a whole room. You can see them, and then to do any work on them, you'd have to actually go in and pull it out and look at the paper. This was, and still is in a lot of places, what we're talking about as an automation system. Maintenance on this was very, very different. And then if you went on the back side of this wall, you saw this panel here. This was actually my notebook. I was sitting on a cable. You can see it, reel. There was my computer, my case, and this was the back of these panels. And at that time, we were only able to look at 3 or 4 controllers at a time. And customers paid a lot of money for us to come in. It was very risky, very dangerous, and you can see it was a spaghetti mess to get data. The good thing is that when these systems broke, it really wasn't, I mean, it was bad, but it wasn't catastrophic. One of these could go down and, well, I'll get to it later. That's not true anymore. And there wasn't so many. So if it took us, in this case, an hour to find a broken asset, within 4 hours I would find it. That wasn't too bad. What about today? Fast forward to today's systems. This is what you're looking at. Over here you can see there were physical space constraints based on the size of your wall. Today it's not that way. You have operator displays that give you more visibility than we could have ever dreamed. You have process charts that have more information that you can even grasp. So you have, and it's not uncommon, this represents 400 control or automation systems, which isn't uncommon. I've seen some sites that are up to 2,000, 2,500. Now take a look. If you notice, right in the middle, I've changed the color of it. So that one has the same problem as this one. Using yesterday's techniques, it took me 4 hours to find that problem. How many hours is it going to take to find it here? Literally, it will take so much time that you'll never find it. So what has happened is we've moved into the area where operators, these guys that are running the plant, have to tell the E&I staff when it's broken. So what made the operators expert in automation? So what's happening is a decline in the ability of our automation system to do what it was designed to do, because we're using yesterday's techniques on today's systems. That's what automation service enables you to do, is to expand your scope of what you're looking at. You can't add enough people to do the methods that we used to have. So it's kind of like that whack-a-mole game. You're solving the problem, whichever one comes up. It's a very reactive service. Reactive services are dangerous. They're cost inefficient and ineffective. And you have to wait for a failure before you start. That's not the service of automation, and that's not how we designed it to run. This picture sort of captures the essence of what we're doing with these gigantic automation systems that are put in place for a reason, to make more money for our customers and our clients, and to improve efficiency of taking a raw material and make it a usable material. But you have these gigantic systems. Wouldn't it be nice if we had a mechanism to sort it in terms of a prioritized list that tells us if I have a control problem or a tuning problem or a cybersecurity problem or alarm problem, or do we have, what's the mix of preventive maintenance and corrective maintenance or predictive maintenance? Well, what is that mix? That's what automation services is addressing. The equipment and the maintenance practices, you still have to have those. You still have to do maintenance on the physical equipment that converts the raw material. I'm talking about the automation system that governs and makes the equipment move. That's the service that we're talking about. This, being a provider of automation equipment to the industry and having been one of the designers and developers of our automation equipment, I can assure you that we didn't design our equipment to be turned off. This is an actual case study of a site that I got to visit that shows production trends and control utilization. In other words, how often did they use the ABB equipment or industrial equipment to improve their production. And what you can see here is that you may not be able to see the scale, but this is about an average of 15%. That means that the customer only used the equipment 15% of the time. And when I made the comment, I said, why aren't you using your system? And they're like, oh, well, we only use it in the case of emergency because it does this. Well, they're not waving at me. It's causing variability in the process. And you can see where a few poor guys tried to use the industrial equipment. They tried to get up to close to 70 or 80%. Look what happened to production. It dropped. If you're an operator and the button you pushed makes your life worse, how often will you push that button the next time? And you can see very quickly they quit using it and they recovered. So for that customer, he was saying, I can run my plant better than with your automation system, and I will only use your automation system in a case of an emergency. What he'd worked himself into a situation where the automation system wasn't configured properly. It hadn't been adjusted, it hadn't been maintained. They had the idea that I turned it on when I started, it ought to just run. Well, what had happened over time, valves change, actuators change, instruments change, the settings change. They had worked themselves into a situation that when they turned the system on, they got problems. And when they turned it off, it got better. That is wrong. That's not how we designed it. If you're in that situation, that is the first clue that you don't have a well-distributed automation service solution. We feel, and have data to show, and I'll show that here in a minute, that when your automation system is in use, you will not want to turn it off. If it's off, it's broken. Operators don't turn off features and functions that make their life easier. That's sort of the golden rule of automation service. And this picture was kind of sad for me, and it illustrated what we're seeing as trends, not just in our equipment, but we get to work in the service sector. So I get to work on all the big service automation solutions and systems that are out there. And this is sort of an epidemic. This picture further illustrates that. Now that we're currently monitoring over 20,000, probably closer to 30,000 control loops every 8 hours around the globe. What we're seeing is literally we can measure this degradation of performance. This is what we call the half-life of a control system if you don't maintain it. If you have it perfectly installed at startup, you've got a system that you love, it's working great, 100%, your product's up, you're making money, and then you walk away and say, well, I'm not going to touch that thing anymore. What's going to happen? You would hope that people have this idea that the system will stay flat across here, that their performance will either stay the same or get better. If you don't maintain it, we have found that you have basically a half-life of around 6 months. Maybe it's a year, but that says that in 6 months to a year, if you don't do anything to your automation system, your performance that you got at startup is going to reduce by about 50%. So that's my question to you, is when was the last time you did a survey of your automation system? If it hasn't been 6 months, you have a system that's not operating at peak performance. What we're seeing in industry is this pie chart. What we're seeing is of the automation solutions, all those quartered in controllers that are now 4 or 5, 100 up to 2,000 that make up a huge component of our automation solutions, we're finding that 30% of those controllers are just turned off. They're in manual. The operator had a problem, he flipped it off. 15, and it's more like 20, are out of range. which isn't really uncommon because as a system is installed and the customer gets to learn how to use it, they put their foot on the accelerator and start to speed up. As you speed up, actuators have to get out of the way and they hit a limit. When an actuator is at a limit, you have no control. And so almost half of the controls in your plant aren't doing anything. The very reason you bought your system, half of them are turned off. 30% of them are actually doing the opposite of what you designed them to do. Remember the customer that said it was waving at them? That's what we're seeing. 30% of the time, the oscillations are coming because the control parameters or the actuator or the I2Ps, they're broken or they haven't been maintained. I've seen valve positioners that are full of all kinds of garbage because they got rust in the air and now they're sticking. There's things that cause variability. So out of all the loops, 20 to 25% of them are actually doing the job that they're supposed to do, which is real close to that picture I just showed you that showed 15% control utilization. They only use it when they have to. That's not how we designed it. The reason we got here is we're using yesterday's techniques on today's automation systems. We need a system, we need a solution, we need tools, we need to supersize our ability. We have to take what used to take an hour and take it down to 10 minutes. We have to take what used to take 8 hours and take it down to an hour. You can't do that with the techniques that we used from yesterday. You need a system. You need a solution, and that's what Automation Service Solutions is. These are some other really neat examples that show from a production perspective the financial impact of a well-balanced automation service solution. This top left was an industrial boiler, and you can see that we were able to save them over $100,000 a year simply by fixing bad actuators, dampers, retuning the controllers, changing the function modules to get the air and gas flows right. This shows before, which was the scatter plot. This shows after we fixed it. This is you're no longer heating up air and sending it up the stack. You're putting it in the water and you're getting more benefit from it. These pink dots are when the operators forgot to put it in auto. So now the customer said, we're going to pay you to make sure that our system stays on. That's music to our ears because that's what it's supposed to do. This is one of my favorite pictures that shows this particular one. It was around $450,000 in savings to a customer. What you can see here is before, this was they ran the control in manual. And the variability, this was a large vessel that fed the front end of an industrial converting process. And it was highly volatile. And when we turned the control on, it not only waved, each wave got bigger. That's called unstable. This is the definition of bad. When they turned it on and things were going to go boom shortly. So we flipped it off and we went and did inspections of the actuators, the instruments. We did bump tests, step tests, first principles, and we came up with logic changes, algorithms, adjustments to the instruments, and look what happened. We went from this to this, and it was sustainable, and it lasted. And that particular change calmed down the entire machine, and the customer came back and said, you saved us over nearly $500,000 a year. This was a huge multivariable solution where this was normal. The customer had come to say that this variability is normal. And we're like, that is not normal. That is actually not good. And they argued with us that we couldn't fix it. We're like, well, just let us try. So we went in and provided a well-balanced automation solution, and look what we did. Boom. And it was over $250,000. These three examples, and I've got countless others, is where production people come to us and says, the cost of this service is peanuts compared to the return. Why aren't more people doing it? And I think it's because we just didn't know we needed it. And now ABB is offering a solution to our customers that allow these kind of returns to happen all the time. In fact, we're seeing that if you give us $1, we'll find $10 in savings almost every time. If you went to a bank and said, I'm going to give you $1 and he'll give you 10, how many dollars would you give him? That's what we're able to do with service, is untap potential, things that had become normal operating procedures, workarounds by our operators, we can identify through automation service solutions. A well-balanced solution has to have these four categories addressed. You have to be able to look at the hardware, valves, transmitters, controllers, displays, and you have to have a maintenance management system to do that. You have to look at the platform itself. That's something that's new. The computer, look in your house. How much automation do you have in your home? We have to look at things like loading, data transfer rates, collisions, communications, update speeds, software revisions, antivirus. That's a whole class in and of itself. Control utilization, which is what I tend to gravitate towards. But if the control utilization is off, is it because the hardware's broke, the controls broke? We have to be able to look at control loop performance. How about alarm handling? How about process sectioning, tuning, bump tests, interactions, causality, interactions, that's a whole field in and of itself. We call that advanced services. And then your people. When was the last time you trained them? Are they certified to work on this new equipment? Are they still using yesterday's techniques on today's systems? They're not efficient, which is costing you money. You know, if you have a downtime and it takes 5 hours to fix, and you have 5 of those trips a year, that's 25, or a month, that's 25 hours of downtime. If you had a person that was trained with the proper equipment, those trips could go from 5 hours to 1 hour. You just gained 21 hours of, whatever that is, 20 hours of increased production. That's what we're talking about, is we need a service platform that can deal with all these areas. In ABB, we provide a service solution called Service Pro, where we provide training and methods to be able to help you reach your performance goals. There are several systems out there, but Service Pro is the one that we provide to address this. And we break service into these categories. There's preventive service, preventive maintenance. That's regular checks. That's like your oil change on your car. There's some checks you just have to do. Support is typically where we're working with your operators, phone support, technical support. Then we can get into administration, where we have a service agreement with you, and we want to reduce the cost of that agreement so that you can maximize your dollars for improving your automation system. So we measure that. We look at scheduled corrective. Those are things that during our rounds, or maybe even a preventive, predictive service found, and then we schedule those and fix them in times that aren't going to affect machine runtime. Those are scheduled corrective. This optimization or process services is the one that talks about advanced services. It's dealing with the process, the information that's flowing through your industrial plant. And then we get into unscheduled corrective maintenance. Those are the bad ones. Those are where, and they're going to happen. No matter how great this is, you're going to have a problem. So are you set up to resolve that problem quickly? Are you able to get back online quick? Unscheduled corrective is where you have a failure that we didn't know about. If you're tracking all this information through some sort of a maintenance management system broken into these things, we've been able to identify ratios that are proper in how much your hours should be distributed amongst these service categories. And that's what I'm going to show you next. What we're finding is, what I was just sort of alluding to, is it really comes down to almost a philosophy to service, is if you run to failure, then you know it's broken, but you never know when that failure is going to be. And so what happens is your reactive services, you're reacting to a problem. And our plants and industrial sites are getting so big, it's hard to fix all of them. So you only fix the most serious ones, and then the other ones just kind of go unattended. So what happens is our reactive service is expensive because you have downtime. Unscheduled downtime has a direct impact on overall equipment efficiency. You don't want to do that. You want to try to catch the problem, you map it into a scheduled downtime. And typically preventive maintenance just isn't really done. When we put in a service program, we can migrate the service effort so that we can increase our preventive and proactive services. And by doing that, we can drive down the expensive, unscheduled corrections. So that's called a proactive service. Proactive services, how do we get there? What do I mean by a well-balanced service distribution? That's this picture. I recently was called into a site, a corporate site that had facilities on actually both sides of the world, but they made a product mix that overlapped. So that inside where they overlapped, they made the same product. So in one part of the world, they made the same product, they had the same equipment, the same automation, even the same raw materials. But on the other side of the world, that had the same equipment, same automation, they couldn't make the product. And it was getting heated because the plant or the facility was getting ready to be closed because they couldn't make this product. And we got called in to evaluate what's the difference. On paper, they looked identical. And we started doing research and identifying the service distribution. What we've got here is these black bars are what we have found. We've now got over 1,000 years of service activity recorded. Those 1,000 years of service activity tracked in those categories that I talked about earlier have found that customers that are making good product, good quality, they have a good relationship with us, they manage their service according to this distribution. They've got a lot of preventive maintenance that's the right preventive maintenance. They have support for their operators and phone support and technical support. We have minimized the cost of the service through our administration. We have handled scheduled corrective so we can find things and fix things. And we've added advanced services, which is the process component. So as you get further into your understanding and stability of your equipment and your application, now it's making all that stuff work together. That's this. And this is unscheduled. So notice we balance the service distribution to drive down unscheduled corrective maintenance. Now, that's our goal. That's what we found over 1,000 years of service measured and sorted, and we said this is the goal. And that's what we feel we need to tell you as a customer. Whether you do it or we do it or somebody else does it, this is the service strategy that you have to have, is you have to have this distribution. This increases the life cycle of your system, which is great, and it reduces the cost to produce, increased production and quality. Look at the difference. The green side is the customer that was making the product and they were happy and they could sell it. The red side was the customer that couldn't make a product and was unhappy and the plant was about to close. Can you tell right off the bat what's the problem? Look at this. Unscheduled corrective maintenance was their philosophy. They would run to failure and then try to fix it. There was no proactive service. There was no, it was interesting, the stuff in the middle here was very similar, but the proactive and reactive is what tipped the scales. When we introduced this and showed it to them and then set up a corrective plan to drive down the unscheduled corrections, then they were able to keep the plant running and things calmed down. So we have case after case where we can show that a managed service solution just makes things better. In addition to that, what we're finding is the comment about whether your people are skilled to work on that equipment. The goal, we now have certification plans and we can measure the skills and the training of your staff. And I did that at both sites. The site that was proactive was very close to what the goal is for that particular service engineer. And whether it was their guys or our guys, they made a conscious effort to invest in the skills along the certification plan. The reactive training had the idea, when it's broken, we know what to fix. I don't need to do maintenance. And so there was no training. So you can see there was a huge gap in skills. And so really they were using 20-year-old technology to fix today's equipment, which resulted in failures. Failures which made it difficult to run, difficult to operate. It was costing them more to make it than the money they could make from the end product. It was the same equipment, the same automation system, and the difference was a philosophy on service, period. And by introducing a proactive, well-distributed service, we were able to turn that place around to where they're now making money and they're still in business. In addition to that, we're talking about tools. Every engineer has a workbench full of tools. Screwdrivers, Phillips, flatheads, hammers, and we typically navigate or gravitate towards the one to solve the problem. In this automation world, the tools are different. They're no longer Excel and PowerPoint or MATLAB and Simulink. Although those are nice applications, we need purpose-built solutions that allow us to data mine much, much faster. So this is an example of a portfolio of tools that you need to be able to have at your facility. We call them workbench tools. And this is in the area of loop performance. What are you doing for data collection? In the old days, it was hard to get data out of a system. Today, with OPC, you can get more data than you know what to do with. And how do we collect data without harming the system? What about calibration and setup of your controllers and your applications? What do you have to quickly look at your fleet of 1,200 I/O points? Analysis, power spectrums, histograms, autocorrelation. What are you doing in that space? What tools do you have to quickly tell you where you have problems, causality, interactions, cross correlations. What are you doing in the area of identification of process parameters, process models? How do you figure out the interrelationships? Because that's crucial for setting up your tuning. How are you doing your tuning and your simulation and making sure that you have a process to address automation needs? And then reporting. What kind of reporting do you do? What kind of reports do you have to represent when you did a control problem or an alarm issue or cybersecurity or actuators, drives, instruments? There's a portfolio of tools that are aligned to assets that we have to offer. We call those workbench tools. We also recommend that we have a service portal. We call that ABB Service Port. Service Port is a safe, secure warehouse of information that allows you to safely connect to your control network. Whether or not you come in from outside through a remote expert or go locally, we recommend having a service portal. It's safer. If this goes down, it doesn't affect your running network. That's important. Like I said earlier, if in the old days, if a controller went down, it really wasn't that big a deal. Today, if a controller goes down, things can go bad very, very fast. So we recommend as a safeguard having a service portal that you do your work through. This way you have a purpose-built solution that can look at the different assets and provide you information with key performance indicators designed for whether it be control loops or security or actuators or transitions, efficiencies. We have a whole list of solutions that can monitor your equipment, your process, or your application. But what this allows us to do is for you to get faster response to troubleshooting. How can I get to the customer faster? In the old days, I'd have to get on a plane and go. So you were looking at downtime for 1 or 2 weeks if I wasn't tied up somewhere else. Literally today, with a phone call and a secure connection we call remote access platform, you can get anywhere and solve a problem literally in minutes that would have taken weeks. How much is that worth to you? It can be a lot of money to be able to, and it's kind of scary in today's world with the threat of cyber and all that, but I must tell you that a person with a thumb drive plugging in at site can even be more dangerous than a person remoting in from the other side of the world. So cybersecurity issues are crucial, and that's something that's just now coming to light, and we have a whole service suite just around that. But we recommend a service portal. We call it ABB Service Port. When you put all this together, what we like to say is when you install a system, the project's, a new system, whatever it is, there's a lot of activity and the performance usually goes up. Now, if you walk away, this dotted line represents the trajectory of system performance. And what happens is you go from this is still better than if it was off. Ooh, why did we get this thing? And boy, I can't wait till it's out of here within 10 to 15 years. That's what we want to avoid. If you don't do automation service, your system is going to be a boat anchor within 10 to 15 years and you can't wait to get rid of it. With automation services that are well distributed and well balanced, you can go the other way where you continually get better. You go from hey, this system's great, I like it, boy, I want more of it, let's upgrade it and keep it going. That's what automation service can do. When I talk about increasing the life cycle, so that you don't have to, your evolution planning, what do you have in place for that? Parts management, how do you get the right parts? How do you know if you have the right parts? How about your balance of workforce? How are your hours being distributed? What workbench tools do you have? How do you get to your site? These are all things that make up a well-balanced service portfolio. Again, whether you do it or we do it together, this is what our goal is. When you take people that are trained and certified and add methods with Service Pro that look at 1,000 years of best practices, workbench tools that are designed for a purpose to improve your automation solution, you take a service portal that is like an engine that is just running, and you put all those together, it provides literally lightning in a bottle. And we call that a well-balanced lifecycle service. And that's what ABB can provide to our customers. And that's what we're talking about as trends in automation service solutions for the 21st century.